Okay, in last class we were discussing about stability and central gravity. Today we will start with turning effect. Turning effect is when forces are trying to turn an object, as it is very clear from the name. If forces are acting on an object, and remember, to use turning, there must be multiple forces acting at the same time. When multiple forces acting on an object at the same time, they are not acting the same line of action as we discussed earlier here. Then they produce turning. And when there is a turning effect of force, it can either be proper or easier to produce. But in an easier way. So, we did turning effect. We also did principle of movement. So today we will be doing some questions for turning effect. Okay. Let me bring some questions.
A stationary object is acted upon by a number of forces. State the condition which must be true if the object does not accelerate, does not rotate. If an object is not accelerating, there must be no net force. There must be no net force. Does not rotate. Clockwise movement about any point is equal to anti-clockwise movement about the point. This is a very long way of saying something very simple. You know how I can say it simple? I can say does not rotate if there is no net turning effect. Okay, if an object fulfills both of these conditions, it means this object is in equilibrium. Now, figure 3.1 shows a boat that has been lifted out of the river. The boat is suspended by two ropes, T1 and T2. The weight of the boat acting on the center of the mass is 24 kilonewton. The tension the ropes are T1 and T2 determine the moment of the weight of the boat about P. So in first part, he's asking us to calculate what? Moment. What is the formula for moment? Moment equals to force multiplied by distance from pivot. Pivot is the point about which the object can or will rotate. So in this case, he has selected a pivot point for us. He's giving us P as a pivot. Because he's saying about P. When he says about, it means he wants us to consider P as a pivot. So moment is force multiplied by pivot. And whose force? The weight? So weight will be considered as a force. So 24,000 Newton is acting 0.4 meter from the pivot. This moment will be 24,000 multiplied by 0.40. 9600 Newton meter.
Teacher, is it okay if we wrote 9.6 kilonewtons?
Okay.
9.6.
Voice was breaking. Okay, you can say
If-
9.6 kilonewton meter.
Yeah. Okay.
You want to say 9.6 kilonewton meter. That will be perfectly fine. Fine. Now, the tension T1 and the tension T2. Now, T1, if I consider P as a pivot, then the weight is producing an anti-clockwise turning effect, and tension will be producing a clockwise turning effect about P. Okay. Now, how much clockwise turning effect T1 produces about P? That will be T1. I'm considering force of T1 as T1. T1 multiplied by, how far is T1 from pivot P?
1.6 meters.
So it will be T multiplied by 1.6. Yes. So that will be the clockwise turning effect T1 is producing about pivot. Now, what is the clockwise turning effect? 24,000 Newton producing about pivot. That will be 24,000 multiplied by 0.4. And we have already calculated that anti-clockwise turning effect that will be produced by the way about the pivot. So I know he has that it is stationary, means in equilibrium. And when system is in equilibrium, clockwise and anti-clockwise turning effect at any point are supposed to be equal. So clockwise turning effect will be T1 multiplied by 1.6 will be equal to 24,000 multiplied by 0.4. So T1 equals to okay, there is one digit after the decimal, one digit after decimal, so you can cancel the decimals over there. 1 was 60, 6,000. So T1 is 6,000. Just 1 second, my
So I
board
can't
got
see your screen.
offline. Just 1 second. Now you can arrange and how will you find T2?
By finding the anti-clockwise, and then they should be equal.
And you can see as pivot then, because if you consider P as pivoting on the pivot and it's this from pivot will become zero, turning effect will become zero. So P2 is not producing any turning effect about point P.
So I still can't see your screen.
Yes, I'm trying to get there. The just one. Hello.
Yes, sir.
Can you hear me?
Yes.
Yes, sir.
Okay. I don't know when did I lose the connection. So the last thing I was saying that clockwise and anti-clockwise turning effect are equal, and we can make an equation and find the value of T1. So I got T1 equals to 6,000 newtons. Do you understand that?
Teacher, can you show how you got this formula?
Listen. I considered P as a pivot. So when I consider P as a pivot, the force that is acting on P will get out of the calculation. The reason is because its distance from P is 0. Let me go to the diagram here. So P is a pivot. If I consider P as pivot, which force will be completely irrelevant because the force that is acting on pivot has a distance 0 from the pivot. That's why this force will not participate in the makings of turning effect. I hope you can
Okay.
see the T2 is acting on pivot. So that is out of the question now. How many forces are left? 24,000 Newton force and T1 force. So one of the force is producing anti-clockwise turning effect, the other force is producing clockwise turning effect. I find clockwise turning effect in terms of T1. That will be T1 multiplied by 1.6 meters. Because T1 is acting 1.6 meter from the pivot. Now, how much turning effect? 24 kilonewton is producing about pivot. We have already calculated this part in the previous part of the question, but we can do it again. 24,000 multiplied by 0.4. So 24,000 multiplied by 0.4 will be anti-clockwise turning effect. T1 into 1.6 will be clockwise turning effect, and clockwise and anti-clockwise turning effects are equal. So what did I do? I put them equal to one another. Yeah. So I hope you can see it. T1 multiplied by 1.6, which will be clockwise turning effect, is equal to 24,000 multiplied by 0.4, which is anti-clockwise turning effect. If this system is
Okay, sir.
in equilibrium, which is said because the board is stationary, that means clockwise and anti-clockwise turning effects are equal. Just solve it. Yeah, just put the values in calculator. 24,000 multiplied by 0.4 divided by 1.6. Or take a feast of math, try to do it this way. Okay. If there are same number of digits after decimal, you can cancel a decimal with decimal in numerator and denominator. And then simplify this. You'll get this. Now, how will you find T2? How will you find T2?
Teacher, shouldn't there be no force because it's like on the pivot?
All right. No, it is still a force. It will not be producing any turning effect, does not mean it is not a force. It is still a force. Now, there is one way that, and I will recommend that you should try it with both ways. What you can do is now you can consider this as a pivot. P1 as pivot, and now the weight will be producing a clockwise turning effect, and this force will be producing anti-clockwise turning effect. You can put the clockwise turning effect equal to anti-clockwise turning effect and find out the size of force P. This is method one. Okay, and there is an easier method. If this system is in equilibrium, total upward force is equal to total downward force. Total downward force is 24,000 Newton. Total upward force is 24,000 Newton as well. Out of which I know that this force is 6,000 Newton, and I don't know this force. So one of the forces is 6,000 Newton, the other force is question mark. I think if I do simple mathematics, I can find out how much T2. But I will recommend you practice it both ways and get the same answers. You can consider T1 as pivot and then measure the clockwise and anti-clockwise turning effect and find the value of T2. Okay. Okay. The moment of a force about a pivot is equal to force multiplied by perpendicular distance of force from the pivot. Now, this is the diagram, and the question is state the name given to the point at which the weight of the rod acts. It is called center of gravity. We did that yesterday. Calculate the mass of the rod. What is the connection between weight, mass, and gravitational field strength? Weight equals to mass multiplied by
Gravity.
gravitational field strength. W equals to mg. One thing that you have to be careful, weight will be in newtons, mass will be in kgs, and gravitational field strength is in newtons per kg. So calculate the mass of the rod. What is the weight of the rod? 160 Newton. If weight equals to mg, what will be m equals to?
W by G.
The value of g near surface of earth is 10. So 160 divided by 10, 16 kilogram. The rod is in equilibrium using data from figure 3.1. Explain why. What are the conditions? Like, there is a 4-mark question. When you get a 4-mark question, you have to be very respectful for that, because sometimes in grade thresholds, the difference between a B grade and a C grade is only 6 marks or 7 marks or sometimes 4 marks. So the 4 marks are very important. Now, using figure 3.1, explain why the rod is in equilibrium. At this point, you should recall the 2 conditions for equilibrium. Let me take you back to the memory lane.
There's no net force.
So the forces are balanced.
Good. That is condition number 1. What is condition number 2? There were 2 conditions for equilibrium.
So the forces are balanced.
And no net force.
Condition number one was there is yes, there we go. There were two conditions for equilibrium. Condition number one, there must be no net force, so no acceleration. And condition number two was there must be no net turning effect. If total clockwise and anti-clockwise turning effects are equal, then there will be no net turning effect and the object in equilibrium if it fulfills both of the conditions. Now, when I see this rod, how much total upward force do you see? I'm talking about the rod, 80 Newton force is acting upward and 160 Newton force acting downward. What is the total upward force?
160
And what is total
Newtons.
downward force?
160 Newtons.
So that means
Yes, sir.
the forces are balanced. So I can start with this. He has already explained that it is in equilibrium. I just have to explain why. Total upward force on rod is 80 plus 80 equals to 160 Newton. And total downward force is also 160 Newton. So no net force. At any point on the rod, actually when you study the physics at high levels, you will understand it's not necessary that the point that we are considering as pivot or the reference point has to be on the system. It can be somewhere off the system as well. At any point on the rod, total clockwise moment is equal to total anti-clockwise movement about the same point as in this case what are the lengths of the rod? 2.4. So this will be 1.2 meter. So if I consider this point as pivot, there will be 160 multiplied by 1.2 as the clockwise movement and 80 multiplied by 2.4 as anti-clockwise movement. About X. About means I'm considering X as a pivot. If I consider X as a pivot, clockwise moment equals to 160 multiplied by 1.2, 192 Newton meter. Anti-clockwise turning effect 80 multiplied by 2.4. So that is also 192 Newton meter. Hence, rod is in equilibrium. So I have calculated the clockwise and anti-clockwise turning effects and showed him that there is no net turning effect. Hence, this rod, this system is in equilibrium. Hope you understand.
Yes, sir.
So we will be starting zooming from the same. We are done with this thing. Tomorrow we'll be doing energy and power. So see you guys.
Allah Hafiz.